For decades, humans have been obsessed with a single question that sounds simple, but hides a deep fear about whether we actually matter in the universe. We ask where everyone is. We point antennas at the sky, we build larger telescopes, and we wait for something to answer back. A signal, a pattern, a message. Anything that proves we are not alone and not completely insignificant on a cosmic scale. But what if that expectation itself is the mistake we never questioned? What if space is not silent at all, and the real problem is that nothing has a reason to respond to us? Humans assume intelligence wants to communicate, because communication is how our species survived and dominated on Earth. We talk, warn, coordinate, and signal danger, so we expect other intelligent life to behave in a similar way. That assumption feels natural. But the universe never promised to follow human logic or human instincts. Silence does not always mean absence, and it does not always mean emptiness or failure. Sometimes silence means irrelevance, the kind that does not require attention or response. When we look at space, we imagine it as empty and waiting, as if the universe is unfinished until someone like us shows up. But the universe existed for billions of years before humans, operating perfectly fine without observers, messages, or conversations. Stars formed, galaxies collided, planets evolved, and life may have appeared and disappeared without leaving traces we could recognize. Human technology only recently became capable of listening, but listening does not guarantee being acknowledged. We broadcast signals into space as if we just arrived at a party and expect everyone to stop and look. But what if the party is so large, so old, and so stable that our arrival barely registers at all? That possibility is far more unsettling than the idea that the universe is empty. Because emptiness suggests loneliness, while being ignored suggests we are simply not important enough yet. And that changes the question completely. The question stops being where the aliens are. It becomes why they would ever bother answering us in the first place. Humans expect communication because our survival depended on it. But that does not mean communication is a universal feature of intelligence everywhere. On Earth, species that failed to communicate effectively disappeared. So we confuse evolutionary success with a cosmic rule that may not exist. An intelligence older and more stable than humanity may see communication as unnecessary, risky, or simply inefficient for long-term survival. Sending signals into space reveals location, behavior, and intent, which can be dangerous in an environment where resources and time are limited. From that perspective, silence is not weakness, but strategy, especially for civilizations that learned survival over millions of years. Humans began broadcasting loudly almost immediately after discovering radio technology, without knowing who might be listening or why. That behavior makes sense for a young species, but it may look reckless or irrelevant to more advanced systems. Another uncomfortable idea is that intelligence does not always need awareness of others to function or grow. Some forms of intelligence may exist as processes, networks, or long-term systems that do not recognize communication as meaningful. If intelligence operates on timescales far longer than human history, short bursts of radio noise may not register as anything important. This raises a disturbing possibility that we are not being ignored intentionally, but simply not noticed at all. The universe may not be quiet because it is empty, but because nothing is tuned to care about signals like ours. That idea challenges the assumption that intelligence naturally seeks contact, cooperation, or recognition. It suggests that our search may be flawed, not because of weak technology, but because of human expectations. And if that is true, then finding nothing does not mean failure. It means we may be asking the wrong question in the wrong language at the wrong scale. For many years, Humans searched for life in space with one simple idea in mind, believing that intelligent civilizations would naturally want to communicate. This belief came from early science and popular books, where advanced societies were imagined as broadcasters sharing knowledge across the galaxy. Thinkers like Carl Sagan argued that communication was a natural outcome of intelligence, because cooperation helped life survive on Earth. But this idea began to change once humans actually entered space and experienced how dangerous and unforgiving it really is. Space turned out to be hostile, expensive, and fragile, where even small technical failures could end missions and lives instantly. As real missions continued, scientific focus slowly shifted from curiosity and contact toward survival, efficiency, and long-term stability. That shift is important because it changes how intelligent systems might behave over thousands or millions of years. In biology and physics, systems that survive longest often minimize exposure instead of maximizing visibility. The more visible a system becomes, the more vulnerable it is to unpredictable events and external threats. Humans learned this lesson quickly through satellites, probes, and long-duration missions in harsh environments. Every signal, orbit, and transmission increases risk, cost, and dependency on fragile infrastructure. Because of this, modern space systems favor narrow signals, limited broadcasts, and controlled communication. This is not paranoia or secrecy, but engineering shaped by real physical limits and repeated failures. If humans learned this in just a few decades, it raises an uncomfortable question about older civilizations. What would an intelligence millions of years older conclude about announcing its presence to the universe? Some scientists studying the Fermi Paradox suggest that silence may be a sign of maturity rather than absence. Advanced intelligence may learn that staying quiet is the safest and most efficient way to persist. The universe does not reward systems that draw attention, but systems that last without interruption. That idea appears again and again in serious books about long-term survival and cosmic risk. From this perspective, our constant waiting for a reply begins to look naive rather than hopeful. We may be listening for a sound that intelligent systems learned to stop making long ago. And that possibility makes the silence feel deliberate instead of empty. For decades, the search for aliens followed a single idea that felt logical and safe, because it matched how humans communicate and understand intelligence. We look for radio signals, repeating patterns, and mathematical messages, assuming that advanced civilizations would want to announce themselves clearly. This approach came from early science and books that imagined the universe as a place full of conversations waiting to be overheard. But this method assumes aliens think like us, value contact like us, and care about being noticed at all. That assumption is rarely questioned, even though it is based on human psychology, not universal physics. Modern telescopes and projects search specific frequencies, narrow windows, and predictable signals that fit our expectations. Anything that does not match those expectations is often filtered out as noise, error, or natural background activity. This creates a strange situation where we may already be observing something unusual without recognizing it as intelligence. Some scientists have warned about this problem in books and papers, arguing that intelligence may not look like a message at all. It could appear as long-term stability, unusual energy use, or patterns that only make sense over thousands of years. Human attention focuses on moments and events, while advanced systems may operate through slow processes we barely notice. Another problem is how search priorities are decided, because money, politics, and national interests shape what gets studied. The United States and other major space powers invest heavily in projects with clear goals and measurable results. Searching for obvious signals is easier to justify than studying subtle anomalies that may never produce headlines. This means our search is biased toward what looks exciting, not necessarily what is most likely. We also assume intelligence would exist on planets like Earth, near stars like our Sun, in ways we can imagine. But physics does not care about human imagination, and neither does evolution on a cosmic scale. Intelligence could exist in environments we consider hostile, boring, or impossible to study directly. Some theories suggest we should look for behavior, not messages, and consequences, not communication. That shift is uncomfortable because it removes the dramatic moment of contact everyone expects. Instead of a signal saying hello, we might only notice silence, balance, or absence where something should be happening. If that is the case, the universe may not be hiding anything from us. We may simply be asking the wrong questions in the wrong way, with tools designed for human answers. And the longer we search without changing that approach, the more the silence begins to feel intentional. There is a strange pattern that almost no one talks about, because it feels uncomfortable and difficult to prove with simple facts. The deeper humans look into space, the quieter it seems to become, even as our technology improves and our reach expands. Early science imagined the universe as loud and active, full of signals waiting to be discovered once we learned how to listen. But decades of searching have produced almost nothing that clearly looks like intentional communication. This raises a disturbing question that feels wrong to ask, but becomes harder to ignore over time. What if the silence is not ancient, but recent? What if the universe was never meant to answer us, because nothing had a reason to react until we appeared? Humanity is very new on a cosmic timeline, and our technological phase is even younger and more unstable. We moved from radio signals to satellites, nuclear weapons, and planetary impact potential in a very short time. From the outside, that might not look like curiosity or progress, but like noise, risk, and unpredictability. Some scientists and authors have suggested that advanced civilizations may avoid unstable systems entirely. Not out of fear, but out of efficiency and self-preservation learned over extremely long periods of time. If intelligence survives long enough, it may learn to ignore young civilizations until they either stabilize or disappear. That would make silence a filter, not a message, and patience the dominant strategy. In that scenario, nothing is watching us closely, but many things are simply not interested yet. This idea feels unsettling because it removes humanity from the center of the story. It suggests we are not being judged, contacted, or studied, only quietly bypassed. The universe may not be reacting to us at all because reaction requires relevance. Relevance is earned through stability, not ambition or speed. If this is true, then the silence is not a mystery waiting to be solved. It is a condition we are currently living inside. And whether that silence ever changes may depend less on who is out there and more on what we become. If the universe ever pays attention to anything, it is unlikely to be curiosity, ambition, or technological noise made by a young civilization. Large systems do not react to intentions, they react to impact, especially when that impact alters balance over long periods of time. On Earth, attention comes only when a system grows too large, too unstable, or too disruptive to be ignored any longer. Forests are noticed when they burn uncontrollably, species are noticed when populations collapse, and systems are noticed when equilibrium fails. If that logic applies beyond Earth, then attention in the universe may follow the same pattern of delayed reaction. That means intelligence is not noticed when it appears, but when it begins to change its environment in irreversible ways. From that perspective, early humanity may be too small, too chaotic, and too temporary to matter on a cosmic scale. Our signals may be loud to us, but insignificant compared to the background processes of galaxies and stars. Books and theories about cosmic survival often point to stability as the real marker of advanced intelligence. An intelligence that lasts learns how not to disturb its surroundings more than how to announce itself. This flips the search entirely, because the goal is no longer to be seen, but to remain unnoticed while persisting. If something reacts in the universe, it may do so only when a system threatens long-term balance. That reaction would not look like a message or a greeting, but like pressure, limits, or resistance. In that case, contact would not be exciting or friendly, but corrective and impersonal. This idea is unsettling, because it turns the dream of contact into a warning rather than a reward. It suggests that silence is not the absence of intelligence, but the absence of a reason to intervene. The universe may not be watching us closely because nothing requires attention yet. And that yet is the most important part of the sentence. Because if attention ever comes, it may arrive not as discovery, but as consequence. That possibility reframes the entire search for aliens into a question about ourselves. Not who is out there, but how far we can go without forcing a response. And whether silence is something we should try to break, or something we should learn to respect. For most of its existence, humanity has been background noise on a cosmic scale, too small and brief to register beyond its own planet. Civilizations rise and fall quickly compared to stars, galaxies, and systems that evolve over billions of years without noticing us. From that distance, our wars, technologies, and discoveries may look like short fluctuations rather than meaningful change. But background noise can become signal when it grows persistent, structured, and impossible to ignore over time. On Earth, systems begin to react only when change becomes sustained rather than temporary or chaotic. A single storm is ignored, but a changing climate reshapes everything that depends on balance and stability. If the universe works in a similar way, attention may come only when patterns replace randomness. That means intelligence is noticed not when it appears, but when it becomes predictable and permanent. Humanity is still unstable, divided, and inconsistent, constantly changing direction and goals. From the outside, that instability may signal impermanence rather than relevance. But if humans begin reshaping planets, altering star systems, or spreading without slowing down, that pattern changes. At that point, activity stops looking like noise and starts looking like influence. Some scientists suggest this is the real filter in the universe, not technology, but long-term behavior. Systems that cannot regulate themselves burn out before they ever matter beyond their local environment. Systems that learn restraint last long enough to become part of the background structure itself. If that is true, then becoming noticeable is not an achievement, but a risk that demands maturity. The universe may not reward expansion, speed, or ambition, but balance maintained over extreme timescales. This reframes progress into something far less exciting and far more difficult to sustain. The question then becomes uncomfortable but unavoidable. Are humans trying to be seen, or are we trying to last? Because those two goals may not be compatible at the same time. And the universe may only notice the difference when it is already too late to change course. Humans behave as if being noticed is proof of success, because attention meant survival in our evolutionary past on a crowded and dangerous planet. Groups that were seen, heard, and remembered had more allies, more resources, and a better chance to survive future threats. That instinct never disappeared. It simply scaled up with technology, turning villages into nations and nations into global broadcasters. We celebrate visibility, growth, and expansion, assuming that bigger and louder always means safer and more advanced. This mindset shapes how we treat space, pushing us to announce presence instead of quietly understanding our limits. Satellites, signals, probes, and plans to colonize other worlds all carry the same message of visibility and ambition. From a human perspective, this feels like progress, confidence, and destiny unfolding as it should. From a cosmic perspective, it may look like instability broadcasting itself without restraint. Psychology explains this pattern clearly because young systems seek validation before they learn regulation. Children demand attention before they understand consequences, and civilizations may follow a similar path. Attention feels rewarding in the short term, but it increases exposure to unpredictable forces over time. Nature rarely protects systems that grow faster than they can stabilize their own behavior. If intelligence exists elsewhere, it may have learned that staying unnoticed is not weakness, but wisdom earned through failure. That would make humanity's loud phase understandable, but also temporary and potentially dangerous. The universe does not respond to confidence, only to sustained patterns that prove reliability over time. Until humans learn to value restraint as much as expansion, attention may remain a liability rather than a goal. This raises an uncomfortable thought about our future beyond Earth. What if the universe is not impressed by ambition, but waiting for self-control? And what if silence is not rejection, but patience extended toward a species still learning how to exist? At some point, the idea of being noticed stops feeling exciting and starts feeling dangerous, especially when the scale becomes impossible to control. Attention sounds harmless until it arrives from something larger, older, and operating under rules we do not understand. On Earth, attention from powerful systems rarely comes as help, but as correction, limitation, or removal of imbalance. Species are noticed when ecosystems collapse, not when they quietly coexist within stable limits for long periods of time. Civilizations are noticed when they destabilize regions, not when they adapt without forcing change outward. If the universe works through similar logic, then attention may never be a reward for intelligence. It may be a response to disruption, triggered only when something grows too fast or too unpredictably. This reframes silence into something protective rather than empty, like a buffer that exists until thresholds are crossed. Humanity may currently exist below those thresholds, not because we are special, but because we are still small enough. That thought is uncomfortable because it removes the fantasy that discovery brings validation or meaning. Instead, meaning becomes internal, built through behavior rather than recognition from outside. If attention is the last thing we want, then restraint becomes more important than expansion. Growth without regulation stops being progress and starts becoming a signal that something is wrong. Many books on long-term survival argue that systems fail when they confuse speed with stability. Fast expansion feels powerful, but it leaves no margin for correction when conditions change. If intelligence elsewhere learned this lesson the hard way, silence may be the result of survival, not fear. They may not be hiding from us, because hiding implies awareness. They may simply not be interested in systems that have not proven they can last. That possibility turns the search for aliens into a mirror rather than a telescope. The real question becomes not who is out there, but how we behave when no one is watching. And whether we can learn restraint before attention arrives for reasons we cannot reverse. There is a growing idea among scientists and writers that silence is not a failure of the universe, but a condition intentionally shaped by long-term survival. Tests are rarely announced because announcement changes behavior, and silence forces systems to reveal what they are without guidance. On Earth, the most revealing moments happen when no one is watching, judging, or rewarding decisions from the outside. In those moments, behavior shows priorities more honestly than words, promises, or ambitions ever could. If the universe operates through similar logic, silence may function as a filter rather than an absence of life or intelligence. Civilizations that cannot regulate themselves burn out quickly, leaving no trace worth responding to or preserving. Civilizations that survive learn to operate without external validation, adapting quietly instead of demanding attention. Silence, in this view, becomes a long-term test of stability, patience, and restraint, rather than curiosity or intelligence. The test is not about discovery, speed, or technological power, but about how systems behave when nothing reacts. Humanity often treats silence as emptiness, assuming that lack of response means lack of consequence. But many systems only react after thresholds are crossed, not while change is still building underneath. That delay creates the illusion of safety, even as conditions quietly become irreversible. If silence is the test, then the universe is not waiting for us to succeed or fail. It is simply allowing behavior to unfold without interference or correction. The uncomfortable part is that tests without feedback feel unfair by human standards. But fairness has never been a rule the universe needed to follow. Silence gives humanity freedom, but also removes excuses. No warning arrives, no signal appears, and no authority steps in to explain what went wrong. Outcomes speak only after behavior has already shaped them. And once outcomes arrive, interpretation no longer matters. If humanity fails the silence, nothing dramatic may happen at first, because large systems rarely respond with sudden or obvious reactions. Failure would not look like invasion, punishment, or judgment, but like limits slowly closing without explanation or warning. Resources become harder to access, margins shrink, and mistakes carry heavier consequences than before, even if causes remain unclear. From the inside, this feels like bad luck, poor timing, or internal failure rather than an external response to behavior. History shows that many collapses feel natural while they happen, because no single moment feels like the breaking point. If the universe reacts at all, it would do so impersonally, through constraints rather than messages or intentions. Nothing would arrive to explain what went wrong or how to fix it, because explanation is not part of the process. Silence would remain exactly the same, offering no confirmation that anything meaningful has changed. That is what makes this idea so unsettling, because it removes the comfort of closure or understanding. Humanity would continue acting, planning, and expanding, unaware that options have already narrowed beyond recovery. From the outside, the outcome would look inevitable, shaped by patterns rather than decisions made at the end. From the inside, it would feel sudden, unfair, and confusing, even though causes were building for a long time. If silence was the test, failing it would not bring an announcement. It would simply end the opportunity to try again under the same conditions. The universe would not move closer or farther away, because it never adjusted to us in the first place. It would continue as it always has, indifferent to interpretation or regret. What changes would not be the universe, but the range of futures available to humanity. And once that range collapses, no signal can restore it. That is the quiet risk hidden inside the silence. Not that no one is answering us, but that no answer is ever required.